The idea is to blink an LED, which is the standard hello world for hardware. So if you actually search for LED, an LED will pop there for you, and then you drag and drop it. So as we remember, all this line is connected. All this line is connected, so they are the same connection. Then we do something. Let's try to see how good this quick intro into an LED. So we notice this is the cathode, is the shorter one, and the longer one has a bend, which is the anode. So it means that goes to positive and the cathode goes to negative. So let's connect this to the positive. I will just do my connection this way. Make sure you don't connect or short circuit the wires. Yep, and because it's going to positive, I'll make it red. And then I'll connect this to negative. Note you can change your layout in any way you want, as long as the connections are made, is fine. This is not a very good or standard way of doing things. I can just make life easy for myself. So you've got red on there. And then you've got the black on there. So if you want to just use the wire, you simply click. You don't need to attract anything. You click and then you extend. It will create a wire. And wires are simply conductors. So it's just electrical connection that we are creating to complete the circuit. And obviously the circuit needs to complete for it to run. Let's turn it on because we've completed our circuit. I press start simulation. Then boom, my LED blows. And it shows that there is power connected, but it shows that my LED has blown. So basically, if this was in the lab, I would have destroyed an LED. And what happened? So what is happening is that the current going through the LED from a 5 volt is too much for the LED to handle. It as an activity, you can find out why this current is actually too much for it, and that goes to Ohm's law, V equals IR. So in order to reduce the current going through it, we need something called a resistor. So let's find resistor. So if you go in there, resistor to resist the flow of current, and we've got a wonderful resistor here. We drag and drop it. So the value of the resistor that we plan to use is 220 ohms. Know that this is kilo ohms. You click the kilo ohms, make it ohms, and you use 220. So once you change the value, you notice that the color of the resistance changes as well, because resistors are color coded for their value. You just select the resistor, press R, and you can rotate it. To rotate it, remember you press R. So I'm going to put a resistance between the anode. If you actually hover over it, it will tell you what it is. So between the anode, all these are connected, and the resistor, and I'll delete this wire and move the wire here so I complete the circuit. And if I simulate it now, you notice that the LED runs. Good. What you notice is that there is a power on here showing the Arduino is on. And then also, obviously, you've got the transmit and the receiver pins on there. So as it stands now, all we have done is to create a circuit similar to this one. If that opens, it is running really. All we've done is this. That's all we've done. We basically just created a circuit similar to this one, where we have voltage going into the well, a current LED, and then also coming through a resistor on there. We don't have to worry too much about this one. It's a tilt resistor, it's a switch really. How do you calculate the 220? Yes, we can actually, we can resolve that later on. I can give you the details as to why it's 220 ohms. For now, I'm just giving you overview of how the software works, and we are just familiarizing ourselves with it.